Okay, we want to graph a polynomial. This is a big idea, not a hard one, and one that we're going to use our calculator to help us with. But there are a few steps. There's things that we want to put in place. So we looked at those on the previous slide, and so hopefully you've got those kind of in front of you. So let's go through this together. So we want to graph this polynomial, x times 40 minus 2x times 50 minus 2x. Well, notice that's nice because it's already factored. That's going to help us find the zeros and do some things. So let's kind of walk through it in the same order of those steps I gave on the previous slide. So the first one was determine end behavior. So let's just kind of picture what's going on. So I'm going to make note of that. So end behavior. This just helps us visualize, well, what are my ends doing? Remember, are they pointed up, or they pointed down, or they opposite? We tell that with the leading coefficient test. So this one is all factored out. So I need to know, well, what's the lead coefficient? Well, to do that, I don't have to multiply the whole thing out. I'm just going to look at my variables. So if I did negative 2x times negative 2x, that would make 4x squared times x would be 4x cubed. So 4x cubed would be the leading coefficient, and that's all I need to know to determine end behavior. So it's odd, so that tells me the ends are opposite, and it's positive, so that tells me that the left hand is down, the right hand is up. So left hand down, right hand up, or in other words, it's doing something like that, just to visualize, right? So I know the left is pointed down, the right's pointed up. All right, we've got our end behavior. Let's find our x-intercepts. And this is where the multiplicity helps us as well. So it's really nice because it's already factored. So x, so is 0. So x equals 0, that's going to be multiplicity 1. Which means it just touches the graph. It crosses the graph, right? It's an odd multiplicity, so we know it crosses at that point. Well, let's see what else we've got. So 40 minus 2x. So if I just set that factor equal to 0 and solve, so we would get negative 2x equals negative 40 if I subtract over. So x equals 20, right? If I divide my negative 2. So x equals 20 is also 0, and there's only one of them. So that's also multiplicity 1. And there's one more, right? 50 minus 2x equals 0. If we solve that there on the right side of your screen. So very similar. So negative 2x equals negative 50. So x equals 25. Also multiplicity 1. So this is going to cross the x-axis at each one of these. Now, I also put y-intercept on there. This crosses right through the origin, right? If I put a 0 in for x, that's how you find the y-intercept. So of course it is 0. So this x-intercept, y-intercept is the same point. Okay, so we've got end behavior. We've got our intercepts, so we've got some points on the graph. We kind of can visualize where it's pointed, but we need to know maxes, mins, kind of what's going on. So let's go right to our calculator and graph this thing to help us. So I'm going to go, just turn my calculator on. Let's go graph this. So get into my graph menu, and it's x times 40 minus 2x times 50 minus 2x. And if I just hit graph right now, we're not going to see a lot. It goes off my screen. I don't know if you can even see, but there's a blue line there. Well, we know x goes way out. It crosses at x equals 20 and 25. My calculator screen defaults to negative 10, 10, negative 10, 10. So let me go change my viewing window a little bit. And this is common. So my x min, we're probably okay at -10. That's not a big deal. Let's make my x max go out to like 30 though. And for my scale, it's not too big a deal. Maybe I'll just go by 5s. And my y's, I don't know what's going on. I'm guessing that it's up there a ways. But let me just go back to the graph to show you something. All right, there it is. So, really steep line here. Hey, it does cross out here at 20 and here at 25 like we'd expect. But I can't really see the graph, right? I still can't really tell what's going on. Based on my end behavior, I think this side should be pointed down. That means this side's got to be pointed up. So there's got to be some turns in here, but I can't see them. Here's one thing that can really help us. In fact, there's a couple ways you could do this. Let's go to the table on our calculator. So right here, so if I push second graph, it's going to show me what are these y values? What kind of values am I dealing with? Well, again, I don't know how well you can see these on the screen, but on your calculator, hopefully you're doing this with me, these are up in like the 6,000, 6,500, and so it goes quite high. So I'm going to go change my scale, my y scale. So my y min, I'm going to go like minus 3,000, and my max, I'm going to go like 7,000. That's above what I saw in my table, so I should be able to see my graph here. And for my scale, I'm going to go by thousands. I just like to see those tick marks on the screen. It's not that big a deal, but okay, now let's graph it. Hey, that looks like a polynomial function, right? So we've got our two turns. It was a third degree polynomial, so we could have n minus 1 turns, and that's exactly what we see. So I've got a max here, right? A local max. I've got a local min. So we're going to go find those values. I see it cross here, cross here, cross here. 3 crosses like we expected. So let's go find this maximum value out here. Remember how to do that? So second calc, and we're going to go number 4, maximum. And we just need to be somewhere left of that value. And then we're going to go somewhere right of that value. And there's somewhere in between. Okay, it's not a super nice value here. Let me write this on my paper. So max, it's like 7, I'll just go to a couple decimals. 7.36 is my x value, and my y value is 6,564. It's a couple decimals, but 0.2 doesn't make a big difference when you're talking 6,500. All right, let's go find that minimum value now. So we want to get this value down here, so same menu, second calc, and the minimum, and let's go down there a ways. Again, just somewhere left of that, let's hit enter. Somewhere right of that, hit enter. And somewhere in between, take a guess. Okay, again, not super nice values. They didn't throw a super nice function at us. That's okay, we're in college algebra. If the answers are too nice sometimes, we probably did it wrong. And that's a minus value now. We're down below the x-axis. Okay. Now, we've got end behavior, intercepts, got our local min and max. Let's go plot those points and see what's going on. Okay. So to kind of help us with that, I already started a grid because I kind of knew what was going to happen here. Graph paper's sure nice. You don't have to have graph paper. You could just draw a line with a ruler or something, or even just try to straight line it. You know, try to make these look nice. Don't stress out about them. But and here's a big thing. I've talked about this before in my videos. I do math in pencil. In these videos, you see me use pen a lot. That's because it shows up better. I want you to be able to see it. But I really recommend doing math in pencil. I almost always do math in pencil. And so anyway, all right, here's our grid. Let's see what's going on. So we know it crosses right here at 0. We know it crosses out here at 20. And we know it crosses at 25. I just tried to scale this out, by the way, so it would be reasonable. So I counted by 5s. I went a couple spaces so they weren't so crammed together. And then I went by thousands on my y-axis because it was way up there. And again, I went a couple spaces in between just to try to make it look reasonable. So let's look at those values we had. So our maximum was at about 7, so it's in here in between 5 and 10. And it was way up at 6,500. I'm just going to ballpark this on my graph. And so again, here's these values we came up with, right? And so if I go about 7 and up at 6,500. Now notice I'm not being super precise. How could I? 7.36, that's super precise. 6,564, so I'm just kind of ballparking where that is. And then our minimum, let's go put in. So it was out at 22.6, so it's about right in between 20 and 25, pretty close. And it's down at negative 564. So here would be 500, so it's a little bit more. So I'm just going to go somewhere like that. Oops, sorry, I'm off my screen there. So somewhere like that for my minimum value. And now, maybe just a couple. So I know that the graph comes up here. I know it comes down. I know it goes there. Maybe just here to the right and to the left, I'll do like an additional point. So I kind of have something to fill in the blanks. I want to make it as accurate as I can. So let me just go back to my calculator. Let's see what's going on at those values. So if I do like trace, you see that on my screen? So if I go to my trace menu, I can type in X values and it'll tell me the Y value. So I'm going to go negative 2.5. Let's just see what that is. Well, it's negative 6,100. So it's quite a ways down there. So I'm going to go down. So negative 2.5. It's like down here somewhere. So again, that's pretty steep. And let's go out here to like 27.5. Let's see what our calculator says. So it's about 2,000. So 27.5. If I go about right there. Now I've got some points. And again, it's just a nice continuous curve, so I really don't need a lot of values in here. You could get a few more if it helped you. In fact, maybe let's do that. Let's just go to like 15. So we have another value in between. And it's right at 3,000. That's kind of nice. So 15 is 3,000. I think that's pretty good. Okay, now here I'm just going to sketch this thing in. And again, don't stress out about it. It is a smooth curve. So just do the best you can. So it's pointed down there. And again, I recommend pencil for this, but let me try to sketch this in here with pen. So up, and it turns, right? And it's coming down, crosses, turns, and there is our polynomial function. Now, that one took a little while to do. They're not all that nasty. We had a weird scale and things. But hopefully that makes sense. This is one we want to feel good about. Those are the basic steps when you go through and you're going to plot a polynomial function.